to wrap this little journey dealing with the graphical interpretation of the modulus function, let's also consider the situation where there is a minus outside of the mod function, right? Or essentially, now we are thinking of what would the graph of y is equal to minus of mod of x will look like. And of course, our starting point should always be input output. If x is 0, y is going to be 0. I assume that you are putting the values of 0 and checking for yourself that how y is 0. Okay, x is 1, y is equal to how much? If x is 1, mod of 1 will give you a 1, but there is a minus outside, so the overall result will be minus 1. If x is 2, the overall result will be minus 2. Okay, so I see what is happening here. Let me also think of the situation in the negative domain. When x is equal to minus 1, you put a minus 1 here, mod of that will give you a 1 and a minus of that will again give you a minus 1. If you put a minus 2, mod of that will give you a 2, but there is a minus outside, so you will get a minus 2, and you can build that story and then you can plot it on the Cartesian coordinates or your graph story, right? So x is equal to 0, y is equal to 0. Where is this point? Here is this point. X is equal to 1, that means 1 unit in this direction. Y is equal to minus 1, that means 1 unit in this direction. So this point will be so, right? So this point is 1 comma minus 1. Next point is 2 comma minus 2. So 2 and minus 2 somewhere here. And I can now, actually I just needed 2 points to draw the line. This is again 30 seconds of extra time for the beginner or the person who's worried about the topic, right? Similarly, if I say minus 1, when x is minus 1, y is equal to minus 1. So this is minus 1, x is minus 1, this will be the coordinate. And that's why the day 0 level clarity in placing the coordinate, then you can do anything, you can make any graph. And I just connect it and draw the line and I'll be done. So I see if my mod of x was like this, the minus of mod of x is like this. So this function is y is equal to mod of x, and this function is y is equal to minus mod of x. So a quick way of thinking would be, take the function and just invert it, make a copy of it downwards, and you have the new function. Also, again, think of your function, the standard function again. At x is equal to 0, y was 0, not a problem, right? I'm now thinking of the usual y is equal to mod of x function. At x is equal to 1, if you put 1 here, you will get a y is equal to 1. So at x is equal to 1, you have a 1. So now I am also thinking, I know how mod of x looks like. I just have to throw a minus outside it. That means whatever was positive will become negative. So this point, x was 1, y was 1, will become negative. That means x will still remain 1, but y will become minus 1. X is 2, y is 2, it will become x is 2, y is minus 2. So the output, right, because input, output, the final output is becoming negative. So every point you're getting a copy down. For every point you're getting a copy down. Right, so get that visualization going, because then if I tell you, okay, y is equal to x square, the graph looks something like this. Right, we might have encountered this earlier, or we'll take a look at this again. But simply put, y is equal to x square, if the graph looks like this, the graph for y is equal to minus of x square, I know will just be a inversion of this, right? Also known as the water image, because it is as if you're standing next to the water and looking at your own image below, right? So once I get this visualization going, the idea will be clearer in my head that, okay, I know everything about the mod function already, just the direction of it has changed. Rest of my logic, rest of my ideas will remain exactly the same. So again, now I have a handle on the basic graph of y is equal to minus of mod of x, or a negative mod, right? So I'm going to now play with the same ideas that I discovered earlier. So I'm thinking that, okay, my general graph in this situation is going to be so. Okay, but there are more games being played here. Can I take the 2 common? So I'll get a minus 2, and inside I will get a x minus 3 by 2. Right, because once you multiply it, you will get a 2x. Once you multiply it, you will get a 3. A very common operation that we have used many times before. And then again the plus 3. What does this tell me? What did I learn from my previous lessons? that if there is a minus constant or minus a, the graph is going to shift those many points to the right. So if this was my basic y is equal to minus or mod of x, because of the constant inside the mod, the graph will shift 1.5 units to the right. I'll make a proper version right now. This is just me thinking out loud, right? And why is that? Because if you put 1.5 or 3/2 here, you will get this equal to 0. Forget this for a second. If this was the only part and you put 1.5, this will become equal to 0. That means this will be the highest point or the junction where the two lines are meeting each other. Or draw a table. If you are in doubt, let's say if the idea is not clear to you, you can always pause and learn by yourself. Play with this function, put the values of x, forget this for a second and plot only this. You will see that, okay, yeah, the graph is shaped like this and it is happening at this point. What is this point? This point is 1.5, 0. X is 1.5 and y is 0. Right, so I am using the same ideas as earlier. I am assuming that if we have developed the skill there, we can go pretty fast here, right? Okay, so this part tells me there is a right shift. What does this part tell me? There is a plus 3. That means this whole graph is going to be dragged 3 points up. So it will become, the new shape will become so. So this graph is moving 3 points up. So I hope you can visualize that. Now let me finally plot it. I'm thinking of the location, the x as 1.5, right? That is my starting point. And then this plus 3 is telling me that the graph, the tip of the graph is going to go up to, the high point of the graph is going to go up to plus 3. So this location is the same, x position is the same, and overall coordinate would be 1.5 and 3, right? And I know the approximate shape now. Once again, let me get rid of the y-axis because the graph is not according to scale. But I know the shape will be something like this. Again, the question is, what is the area of this triangle, or how many integers lie inside this region, etc., etc. Later, I can also throw in an inequality here and start working with that. But all of that will come from clarity in the basic design, right? So I have this graph. I know I have to find these points. What is special about this point? Y is 0 here. What was y here? Y was equal to 3 in this story. And as you progress in x, it becomes 0. There is a change of minus 3. But let me not complicate the story. The slope in this story is going to be negative. What does that mean? That means as you increase the value of x, the value of y will decrease. So that's the only thing new happening in this particular story. Otherwise, I have already learned the slope concept. Okay, what is the slope here? Slope is 2. That means for every unit change in x, there is a 2 unit change in y. Whether it's in the positive direction or whether it's in the negative direction, we'll handle fairly easily because both the stories are playing out here. And I can see the graph is going downwards. That means as x goes higher, y goes lower. So the slope is negative, but the ratio or the multiplying factor is still 2. For 1 unit change in x, 2 unit change in y. So you want 3 unit change in y, that means in x you will have to create a 1.5 unit, right? X will change by 1.5, y will change by 3 units. That much is clear. But because the slope is negative, that means if y is going negative, x will go positive. That's the only game I have to play. So x earlier was equal to 1.5. 1.5 plus 1.5, the new x is going to be 3. That means this point is going to be 3, 0. The value of x is 3 and the value of y is equal to 0. Again, using symmetry, I know from 1.5 to 3 the distance is 1.5 units. I will follow the same logic in the opposite direction and I'll move 1.5 points to the left and this location will be 0, 0. Oh, this is 0, 0. This is where the y-axis passes through. So now it's an accurate representation. But for clarity purposes, I did not even need the y-axis for now, right? So, okay, that is one idea, but I'm not happy with that idea. I still want to play with the slope story. Now, if I look at this line, just look at it, it is going upward. That means as x increases, y is also increasing, right? That means the slope for this story is positive 2. As you go from here to here, the slope is positive 2. But I'm already at x and a half. I know I have to go in this direction. So if I change my point of view and I stand here and I say, okay, as I move for x in this direction, the value of y is going to go down, right? Okay, I am at 3. I want to go to 0. There is a change of 3. There is a drop of 3. So x should also move proportionately. And what is the slope? Slope is 2, right? So I hope you're getting the idea that whether the slope is positive, negative can just be a matter of your orientation about how you want to tell the story yourself, right? So now the y is 3 and the new y that you want is 0, right? There is a negative 3. If you want to be technically correct, the slope is also negative, right? If you just want to follow the standard method. So x also should drop by 1.5. There should be a negative. That means the only challenge was here. The new thing was happening here. This one was negative, one was positive. But visually it is so much more clear. As you go higher in values of x, y keeps going lower. That means if you want negative here, you want positive here. But here the story is the same. I might have spent too much time. I hope you simplify it for yourself also. So x was initially 1.5. I want to do a minus 1.5 and the new x will be equal to 0, which I know anyway. Right, so I hope it is very clear that I'm just playing with the stories. Okay, I have one clear view, but after that I also have the comfort. I know what's going on. I can use this point of view or this point of view. It's up to me how I interpret this information. Or better still, I could have just made this equal to 0, solved it using your standard modulus operations, and I would have got two values of x anyway, right? So also hit pause right now and try and work it out. But now if you notice, except that the graph is inverted, all the functions, all of these games that we have played earlier, except as maybe this little bit, and even something like this we have played, because even the earlier graph when we made something like this, right? This line was going up, but this line was going down, but we used it backwards according to our interpretations. So I hope everybody is comfortable with this idea, or they sit down, think about it, find some more help, drop me a message, okay, I need more details on this. But the idea is fairly simple. And the big idea is that once you get a core, you understand how mod behaves overall, then putting a minus is not creating too many challenges, right? I'm covering it in detail just in case somebody is troubled by this, but conceptually it is exactly like what we have done earlier.